Hello everyone, I'm Xiaoqi. After more than 2 years of R&D, repeated testing, and continuous optimization, our QE3 remote controller has finally been released. Today, I finally have the chance to record a quick getting started guide for QE3 and walk you through its basic operation. Okay, let's start with the unboxing. Okay, as we open the box, you can see some incoming inspection checklists here, which are used to confirm that each unit has been checked before delivery. Inside is the controller body. This is its dedicated charger, and it needs to be used together with this matching charging cable for proper charging. And over here, we have an accessory pack for the external video and data link, including the cables and parts. This is the mobile unit for the external video and data link. This is the mounting bracket, helps fix the mobile unit in place. There are also some shoulder straps, warranty cards, user documents, and other small accessories included in the package. Basically, that's everything included in the box. Now let's look at the next. Okay, we have installed the controller bracket. Now let's look at the ports. At the top of the controller, there are various ports. From left to right, these two rows are physical interfaces: a DSC port, an HDMI port, a Type-C port, a USB port, an Ethernet port, and a SIM card slot. This is the TF card slot. One thing worth noting is the rear cover. By default, this cover is closed to protect the internal expansion interface and keep the controller body cleaner and more secure. After opening it, you can see the external video and data link interface, which includes power, serial, and Ethernet connections. This interface is mainly used for connecting an external transmission link, so the controller can work with different video and data transmission modules when needed. These are all the interfaces on the controller side. The QE3 remote controller runs Android 14, so the operating system is quite new, and the overall user experience is closer to a modern smart device. It also comes with several default apps for basic setup and daily operation. For example, Robosn Remote Assistant is an important app used to configure joystick channel mapping, check channel output, and perform joystick calibration. There is also Via, which is a lightweight browser for everyday web access, software downloads, and basic online operations. Another important app is QGC. The pre-installed QGC ground station can be used for flight monitoring, parameter checking, and basic mission. Next, let me introduce a very thoughtful design feature. This remote controller supports replacing the video and data transmission module. In other words, the system already has an internal transmission module by default. Of course, this module can also be replaced externally according to different application needs. For an external video link, we only need to open the rear cover and connect it through the reserved interface. This is our LQ10 external unit. Then we attach it here. Once it is snapped into place, the external video link replacement is complete. If we want to use the fiber optic module instead, we also provide the corresponding solution for that setup. We install it in the same way, and fiber optic video transmission is supported. If we want to use an external video link later, we need to enable it in the Remote Assistant app on the controller. This step allows the controller to switch to the external transmission interface and communicate with the external video and data link properly. First, open the Remote Assistant. In the settings page, we can choose between the internal video link and the external video link according to the actual setup. If the internal link is selected, the external link will not be powered, so it will not consume system power. This helps reduce unnecessary power usage when the external module is not needed. Selecting the external link powers the external module and connects it to the network. At that time, the internal link is disabled and not powered, so the two transmission links will not interfere with each other. This also makes the power supply and signal path much clearer during operation. Okay, next let's look at the joysticks and channel mapping. After opening Remote Assistant, we can see 16 channels on the screen. When we toggle the switches or move the joysticks, each action can be mapped to the 16-channel output, making it easier to check and configure the control response. Here, clicking Remote Calibration starts the calibration process, which helps ensure the joystick output is accurate and centered. This area allows you to change channel mapping. For example, Channel 5 can be mapped to the rocker switch or to the toggle switch, and the values above can also be adjusted freely. It depends on your actual application, aircraft setup, and control requirements, but for most use cases, the default parameters are enough. On the back, there are two buttons, two dials, a 3-position rocker switch, and a 3-position toggle switch. These controls are mainly used for quick function switching and auxiliary operations during flight. One thing worth noting is the H button, which is designed as a convenient shortcut button for users. The H button is for return to home, and it requires a long press before it takes effect. which helps prevent accidental triggering during operation. This one is also a momentary button, and this is a 5-way switch for additional function control. Overall, 16 channels are quite enough for most industrial applications, including flight mode switching, payload control, and other auxiliary functions. In Remote Assistant, you can open the settings page and change the SBUS serial mode according to your connection requirements. You can set it to raw serial mode, enable automatic inversion, or set it as an SBUS interface, depending on how the flight controller or external device needs to receive the signal. This mainly depends on what protocol is supported by the SBUS interface of your internal or external video link. Different devices may require different signal formats, so we need to match the protocol correctly. By default, it uses the standard BUS protocol, so here we switch it to the SBUS protocol. There is also an input device option where you can enable the HID gamepad function. After enabling this function, the controller can output joystick signals in a standard HID format. If your flight simulator supports HID, the controller joysticks can be recognized as a gamepad. Then it can control the simulator aircraft if the software supports it, making simulator training more convenient. There is also a trainer control function. Now let's talk about how to pull a video stream on the controller. Streaming is closely related to the video link because the controller needs to receive the video data through the transmission module before displaying it in the ground station software. Let me show a demo first. Here, we use LQ10 as an example. We use it for video stream transmission in this demo. This is the LQ10 mobile unit. Since the controller already comes with LQ10 built in, the controller side works as the ground unit, and here's a normal streaming camera used as the video source. This is the basic link configuration for the demo. The camera is connected to the network card, and the LQ10 mobile unit is powered on to send the video stream through the transmission link. On the controller side, the built-in LQ10 module receives the stream. I have already opened QGC, so let's check the streaming settings and see how to display the video. The streaming configuration is under video. In the video settings, we need to set source to RTSP video stream, so QGC knows that the video input is coming from a network camera or an RTSP stream instead of a local camera source. Then set the RTSP address according to your camera. A normal camera or gimbal module usually has a default RTSP stream address. Make sure to enter it correctly, including the IP address and stream path, otherwise the stream will not work. The other settings can stay at default. You also need to configure the camera MTU, which means maximum transmission unit, and keep it within 1400 to make the stream more stable over the video and data link. Most camera manufacturers support this setting. If there are still streaming problems, they are usually related to the video and data link module. Another factor is QGC's codec support, or the codec support of the streaming app. You can try different streaming software, such as VLC, to test the stream and confirm whether the video source itself is working properly. During video streaming, transmission is related to MTU because it affects how the video data is sent through the link. When the stream reaches the controller, playback is also related to decoding, and decoding depends on how the software app is written. Different apps can have quite different decoding performance, so testing with another player can help identify the problem. By following this quick start video and checking the common troubleshooting points we just mentioned, you should be able to start using the controller quickly, understand the basic settings, and meet most daily operation needs, including link selection, channel configuration, and video stream setup. For more detailed configuration methods, I suggest checking our wiki, where you can find more complete setup instructions, parameter explanations, and troubleshooting guidance. If you still have problems during configuration, please contact our after-sales team. They can help you solve the issue based on your actual setup. Finally, I wish everyone a great experience. See you in the next episode.